Okay, segment 8 begins where we left off, and your job was to complete these two. So if you did not do that, that puts you at a disadvantage because you have to practice this. Okay, I can't overemphasize that enough. Zinc phosphate, potassium bromide, 2 and 3 always tells us we're going to make 6. Down here, 3 waters, lithium phosphate, and by the way, it doesn't matter if you list this one first and this one second, or this one second and this one first, 1, 2, or 1, 2. It doesn't matter the order in which you write them. Okay, so we're going to move on to combustion. And combustion for our purposes is generally some kind of carbon compound plus oxygen will yield carbon dioxide, water vapor, and heat. Okay, now for our purposes in this class, we're going to ignore the heat part, which is kind of unfortunate. But as you learn more chemistry, you're going to learn how to put the heat component back in. Because after all, that's how you have living systems, is you create some kind of heat or energy which drives other reactions forward. The good news on this is that these 3 parts don't ever change for our purposes. Oxygen, CO2, water, oxygen, CO2, water, oxygen, CO2, water, oxygen, CO2, and water. So in that regard, you don't have to predict anything. But what you do have to do is you have to balance. And what you'll notice is sometimes you have oxygen in a lot of places. Okay, so you have oxygen in 3 places, you have oxygen in 4 places, and so that makes balancing a little trickier. So I always start with the carbon, then go to the hydrogen, then go to the oxygen. So let's try a couple. 1 carbon, 4 hydrogens, 4 hydrogens, and then we have 2 oxygens from the CO2, 2 oxygens from the water, gives us a total of 4. So if we get 4 out, we have to put 4 in, which means some number times 2 gives us 4, and we can do that in our head very, very easily. Okay? This one is not quite so straightforward. 2 carbons means 2 carbon dioxides. 3 plus 2 plus 1 is 6 hydrogens, which means we need to make 3 waters. And now let's keep track of our oxygens. We created 4 here, 3 from the water, 1 from the carbon compound, which means whatever we put in terms of oxygen has to equal what we got out. So we created 7, 1 is accounted for here, which means we need 6 more with the oxygen, which means our coefficient here is 3. Okay? All right, I'm going to let you try this one, and then I'm going to come down to this one because oftentimes our oxygen is problematic for us. So I'm going to do this one with you. 8 carbons in means 8 CO2s out. 18 hydrogens in means I need 9 waters, which means I have 16 oxygens from the CO2, 9 from the water, which means I have to put 25 oxygens in. You often get an odd number. Some number times 2 has to give me 25. So I don't let that bother me, and I just say, okay, 25 halves. That's the way it goes. You often get an odd number. To get the 2 out of the denominator, you multiply everything by 2. 2C8H18. 2 times 25 halves is 25O2. 2 times 8 is 16 CO2. 2 times 9 is 18 waters. And that is my final balanced equation. So you're going to want to check it. 2 times 8 is 16. 16 carbons, check. 2 times 18 is 36. 18 times 2 is 36, check. 25 times 2 is 50. 16 times 2 is 32. 18 times 1 is 18. So does 32 plus 18 equal 50? And the answer is yes. Okay? Don't let combustion reactions bother you. In fact, it's hard to move on in chemistry in terms of biological chemistry because this is the fundamental reaction that drives the creation of energy that we need to keep body systems going. Okay, so we don't live very long if we can't do this in some way. Okay? All right, so the first thing you need to do is identify the reaction type and then balance. Sometimes you need to predict products yourself, other times they're given to you. You will have a lot of these on your exam and you'll get lots of practice with single and double replacement labs. Okay, so I'm going to put a star by this. So we're going to have some lab activities and maybe some gizmos activities depending on what semester you're in, where you get lots and lots and lots of practice with this. Okay, so what you're going to want to do is you're going to want to pause and practice 10x per type. Okay, so we have combo, we have decomposition, we have single replacement, double replacement, and now we have combustion. Okay, so you don't want to go forward until you have done this, because when we come back in your next segment, we have to say more about these reaction types. So what you're going to want is, in addition to your periodic table that you always have handy, is you're going to want to have your solubility table handy, because we're going to need that next.